Morning students. Yesterday we saw the concept of subsets and number of subsets also, how we can find for any set. Today we'll go a little further and we'll see some about intervals. So it's a easy but a new concept for you, intervals. So I tell you that about interval, very interesting that is for students. Look at interval, actually very useful for class 11th as well as class 12th and further studies. So very basic concept, that is interval. I tell you, suppose this is a number line, real number line, integer line, whatever you can say. First I am taking to a real number line from minus infinite to infinite, no matter at all. Look at, I'm writing also. Particularly, suppose that this is a and this is b. These are two values. These are two values between the real number, and I am placing my x. X is also a value which is here between a and b. So we have a few intervals which shows different things. So we have a three kind of you can say four kind of intervals: open interval, closed interval, semi-open or semi-closed. Semi-open or semi-closed both are identical, same. So first, open interval. What is the meaning of open interval? I first tell you that x is lying between a and b. Between a and b. So first interval is open interval. Open interval, and it means that x is lying between a and b. Between a and b. So this open interval is given by this open bracket a and b, and it's meaning that x is lying between a and b. X cannot equal to a, x cannot equal to b. Look at my thing, the last sentence concerned that x cannot equal to a, x cannot equal to b. When it is open interval uses, x is exactly lying between a and b, x cannot equal to a, x cannot equal to b. So this is first way of expressing the open interval. Second, the expression I am telling you one by one. This is first expression. This is first expression of showing the open interval. Now I am showing the second way of showing the open interval, that a less than x less than b. One can simply understand the meaning of that x is lying between a and b, x cannot equal to a, x do not equal to b. This is open interval. So look at, if you have this, you can write this. If you have this, you can write this. And third and very important, that how we can represent on the graph. So this is a graph, definitely it is a graph. So again I am making the position of that open interval in the graph section. This is a, this is b, not important infinite here, and I am writing that x is lying between a and b. So how we can represent with the graph? Make an open bubble here, make an open bubble here, and only decorate like that and say that x is between a and b. That open interval shows that x cannot equal to a, x cannot equal to b. Hope what I am actually trying to tell you, you understand that x is exactly lying between a and b. This time x and x is not equal to a, x is not equal to b, meaning x cannot equal to either a or b. So this and this with three expression. This is open bubble, meaning x not equal to a, x cannot equal to b. Okay, so these all way we have an open interval. Now we have second is a closed interval. Look at closed interval. So hope with this you can understand the meaning of closed interval. So first I tell you that first is x is lying between a and b. So in closed interval I would express that this bracket. Look at the bracket. Look at the bracket. X belongs to that bracket. This is a closed bracket called closed bracket, and this meaning is very simple. Again, x can attain any value between a and b, as I told you here, that x may be any value between a and b. This time x can equal to a and x also can equal to b, meaning the value of x may be a and the value of x may be b, or the value of x between a and b. But this time what I used, X cannot equal to A, X cannot equal to B, but X may be between A and B. So here in closed interval, only the meaning that X can equal to either A or B, or between A and B. So this is the first way of representation. Second is this one. So in that kind of expression, it can be expressed like A. Hope you understand. You can also do by your own that X is like between A and B. X may be equal to A, X may be equal to B. That same sense. But look at here, not equal to, because it is open interval. Now in third sense, I would express by the number line. So this is a number line, real number line, and this is A, suppose it is a B, suppose, and X lying between these two. So how will I express? This time I expressed with using open bubble. This time I will use a closed bubble. Look at closed bubble meaning, and just write like that. Meaning X can be equal to X, can be equal to B, or may lie between A and B. So very simple it is. I don't think that's a problematic. Third is semi-open or semi-close. I tell you that semi-open or semi-close. Meaning at one end it is a close and one end it is a open. I think that also very simple to you. So I'm writing that only. X belongs to AB. First this, look at this. Excuse me. Look at this. And one can simply predict the meaning of that, AB. And if you will watch AB, that X is open from A and closed from B, and one can simply understand the meaning that X is actually between A and B. X cannot equal to A for open interval, and X can be equal to B for closed interval. So wherever the closed interval using, meaning X can attain that value. But wherever this open interval, meaning X cannot attain that value, but X always lie between A and B. So this is a simple meaning. And in second sense, how we can create that? This is meaning A less than X less than B, but here it is equal to, look at it. Now X cannot equal to A, but X greater than A, and X less than B, meaning X lies between A and B, and in this sense X can equal to B, but X cannot equal to A, because it is open interval. And third sense is what? By graphical section you can understand that it is a minus infinity, it is a plus infinity, it is X, it is A and B. So I want to represent like that. So where the closed interval is appearing, in that part only use a closed bubble, and where the open interval is using, use a open bubble. And I would say that X lies between these two values, where X cannot equal to A, but X can equal to B. So this is a way, and I think you can also make a different section. Hope now you have seen it all. So I want to rub it. You please view and watch this 2 or 3 times. You can understand by it very well actually. And the fourth is, which is the same name, semi-open or semi-closed, but now this time it will be closed from the left and will be open from the right. So how it will be? X belongs to that. Look at, hope you understand this. Meaning X can equal to A but cannot equal to B. Second way to express that, X, A and B, and this time it is equal to, simple, because X, it's a closed bracket with the A, that's why X can equal to A but X cannot equal to B. And third, and very simple now, the graph section, minus infinite to infinite, where X lies between, represent A and B. First want to plot, and then X equal to A, so that this is closed and this is open, and your X is lies between these two. So very similar. Now till now you have understand about all these things. So I don't think that I have to tell you about all. Now I'm rubbing all, and I will tell you some more important thing. Look at, suppose, and what I'm going to tell you, this will actually useful for this year also. 12th when in class 12 we have lots of portion of this, so concern that we are using, suppose this is number line infinite to infinite, and this is A, not B, and your X is lying here. So what kind of situations may be there? First I'm telling you that X is lying in this particular interval, so I'm taking first X belongs to A infinity. And what do you take out the meaning from this? X belongs to A to plus infinity. it means that the plus infinity is not very important to write plus, but still for mentioning the direction I have taken here, that what you will take out the meaning from here, that x is not equal to a, x cannot equal to infinite, and very simple and sensible thing that x cannot never equal to infinite, meaning all the time as far as the infinite is concerned, you have to use the open bracket. It cannot be used there a closed bracket. If I take a closed bracket, it is nonsense, because this time x will be equal to infinite, and infinite is an imaginary value. It cannot be used anytime, so that it is always plus infinite. And please take out the meaning. Suppose it is first and it is second. So what do you think about that? X belongs to a to infinity, and try to take out the meaning. Now the question is coming in your mind, that it is an open interval, use an open bubble here. Sorry, but it is infinite, so we need not use any special bubble there, because it is infinite section. It is automatically meaning it is a open interval, meaning it is infinite. So near the infinite we should not use the open bubble. At the particular, which is actually absolute a, perfect a, you know the a is constant there. So this meaning that x lies between a to infinity, but x cannot equal to a, and it's automatically meaning x cannot equal to infinite. And this also can be written in third way, like a less than x less than infinite. Very few it is using, but still I have told that it is a meaning all the same. So this is very important, as I'm telling you here. So second, if I'll tell you, look at the thing, and now take out the meaning of this. Suppose I'm writing that only. So what do you take out the meaning of this? This is first. Now what do you think? When if I write in this way, what I write? X belongs to, x may be equal to a, and maybe between a to infinity. So I'll write only a to infinity. Look at. So near to a I use a closed bracket, because it is a closed bubble I use there. So whole meaning is x can equal to a, but x cannot equal to infinite, which is very genuine, and x always lie between these two. And third is very simple now. When a less than or equal to x less than infinite, very simple meaning that x can equal to a, and between these two. So I don't think that I'm telling you a very tough thing. Very simple. As it is from the right, it also can create for the left side here. If third I'm telling you, look at the thing. Suppose it is a, it is infinity. A very important thing I'm telling you. Suppose the situation I have created like that, and take out the meaning of that. What is its meaning? That x lies between these two, and open, definitely it is always open. So concern one thing, while writing the interval, you always use left to right, meaning you have to start your writing from left to right, meaning if you will write x belongs to, this is first graphical meaning, this is second interval meaning, how will write here like that. This is from a to infinite, so left value will be written first and then right value. Here, what is left value first? Minus infinite. So you will write minus infinite to a. This is always open, because I have told that near the infinite, either if it is plus infinite or minus infinite, but use the open bracket that time only. But for a, you have to go with your condition, questions condition. By the way, actually I'm taking here the open interval, and I'm telling you that x lies between these two, but write first this one, because it is left and this is the right side. So from left to right, we used to write that, and minus infinite to a, I'm writing that. This open interval shows that x not equal to a, but x lies between these two values. So this is very simple. And third, I think for that you can understand minus infinite, x and a. And the fourth way you won't understand about what I'm telling you. It is a and it is plus infinity. This is close I'm using, and whole meaning is what? X lies between. This is first way to express in graphical section, and second in interval, how will write? It is minus infinite to a closed. So don't worry about infinite, that whether what sign will use, it will always be used there open interval. And the third is what about that? Third is like that. So minus infinite, x and a. So this is a way. Hope this all two boards you have got now, because it is nothing there. It's all very easy. So let me rub it, and I want to go further little bit. Look at, I tell you. Now I'll go on this is interval. So all the aspect of the interval I have told you. Now power set will come. Look at power set. How will define that? Look, the set of all the subsets of any set called power set. Very simple definition, and try to concern that. The set of all the subsets of any set. Meaning if you have any set, find its all the subsets and make it set. It will be power set. I put example. Example. Let A is 1, 2. This is a set. I asked you that find out its all the subsets. So I taught yesterday that subsets are first subset is 1, second subset is comma 2, third subset is itself 1, 2, and fourth is genuine, natural, 5. Empty set is always subset of any set. So 1, 2, 3, 4. These are subsets of A. And now it is written the set of all the subsets, meaning you have created the subsets, now make it set. This is a power set. So power set is given by P of A. So A is a set, P of A meaning we are creating the power set for A. And that is only the set of all the subsets. Now these are elements. So very important, and the vital thing I'm telling you. Look at. In always, if you will watch this, I tell you that in a set these are elements. Now we have created subsets. Now we have created one more set of the subsets. Now I ask you that what is this particular? This is an element of this. Even it is set, even it is subset, but it is an element. So in power set, all the element in the form of sets. In power set, all the element are in the form of sets. I cannot write such like a 2 or something like here. 2, 3, 4 cannot be containing in any power set, because power set is actually important, because power set is what? It is none else. It is a set of subsets. Meaning all the subset when we arrange in another set, it's a new set called a power set. So in power set, all the element will be in the form of sets or subsets, whatever you can say. So this is a power set. I ask you, how many elements in the power set? How many elements in the power set? So this question already have explained yesterday. Look at number of subsets are being here. These are element now of P of A. Again I repeat the sentence. These are subsets, and number of subsets I told you yesterday 2 to the power n. Here also, because these subsets are arranging in a power set, so I ask you that this is what? One element of this. This is what? Another element of this. So all 4 elements they are. So these are called elements of power sets. So it will be defined by 2 to the power n, same formula, because it is none else, they are subsets actually. I told you yesterday how we can find the number of subsets 2 to the power n. 2 to the power n meaning number of element of A, 2 to the 4. So 1, 2, 3, 4. These are the element of power set P of A. Hope student you have got. Very important. I ask you once, I tell you once again, in power set you will not get a simple ordinary number. Like anytime and all the time P of A will not contain this kind of element, because these are simple element. But P of A is not a simple, it is a special one, because it is containing the subsets. So all these form will be in the form of subsets or sets. So this is an important sentence which I wanted to explain. So I think you have seen it, and now you can understand by watching this once or twice. Now we have exercise, and I request you complete this exercise from your side. 1.3. Try to do. I'm not saying that I will leave whole the questions, whole the exercise, but I will tell you. But first you start from your side by just seeing the yesterday's videos and today's video, because in these 2 videos I have taught you that subset and power set and intervals also. So do try from 1 to 9. I will tell you some good question tomorrow. Thank you.